Hi, this is Dave Redder, and this is the third installment on the Iterator pattern as promised. And this time we're going to do things a little bit differently. We're not going to use the gang of four Iterator pattern layout, but instead we're going to use what Microsoft has chosen to put in its .NET framework, and it allows the Iterator to be integrated fully with the looping structure in the .NET framework. So we're going to show you how to do that. This is a really simple little application, although, on the surface, but there's a little complexity that we'll have to deal with. And then the Iterator part from Microsoft is a little bit more complex than the gang of four part, but it's also quite nice. So let's look at this app. This is a mailing lists app. My family has always had Christmas, pig roast, and family events, and we try to keep lists separate for the purpose of sending out invitations or gifts. And so if I wanted a Christmas list, I could come here and click on that box right there, that checkbox, and you'll see that I've got members of my Christmas list mailing list. Now, of course, I could put more information here, like an address and a phone number or whatever, but this is just a demo, so we don't care about that. What this means is that Deb is part of the Christmas list, Terry is part of the Christmas list because they're capital C's. But only those people with a capital P, for example, are members of the pig roast list, Terry not being one of them. So if I were to unclick Christmas and click on pig roast, you'd see that Terry is not among them. But some other people have shown up, for example, Seven and Dave, that weren't on the Christmas list. If we want everybody that's on either of the lists, then we can simply click on both of them at once and we get those. Now, as you can see, we can't really tell what the underlying structure is that holds these separate lists. There's a Christmas list, a pig roast list, a family list, and I can look at any pair of them. I can look at any single one, or I can look at all of them. And something in there is allowing me to iterate through these individual lists, and we're going to go take a look and see what that is. The key to this is this piece right here, because this is just a standard old for each control structure in C# in the .NET framework, and it uses what we're just about to see in order to be able to iterate through this thing called ML and to deliver one at a time the members. It does not go and list them all into a specific list and say for ICO1 to count. It simply is going through some other structure that we can't really see what it is right here, although you'll be able to see it pretty easily. That allows us to use this iteration concept and also allows us to extend this concept into more lists if we wanted, actually pretty easily. Also, I want you to notice that right here, all of this code, just as you see it, at least at this point, this is November 27th of 2017 at 8 o'clock in the evening. This code that you're looking at, I just did upload it to GitHub. It's called Kalen Tutorials, and there's only one there right now. I've got the others, some of the others, on a different GitHub site, and I'll be moving them over here in the near future. So this one's called Iterator Pattern Part 2.git, and you're welcome to go grab that. It might be a good idea to grab it before you watch the video and see if you can follow along there. So let's take a look and see what we have. The first thing that I've got here is this public enumeration. This has nothing to do with the enumerators and enumerables that we're going to talk about here pretty soon, but it does have to do with this business of having three things. Notice Christmas, it says, is 0, pig roast is 1, family is 2. This is essentially a way, the way I'm using it, of naming the integers so that they mean more to us. Then we don't have to remember that 0 means Christmas. We just remember that Christmas means Christmas. So let's take a look at this. This is the form, and the form has two items in it. It's got the member list itself, which is the list of members that are in my list of people, list of friends, if you will. And this is the list types that go with the iteration that we are concerned with now. For example, notice that this is a list of list types, And if I had checked Christmas and family, those two list types would be in this list, and pig roast would not be. So then I'm going to create a mailing list object. And we can see we've got a mailing list class up here we're going to look at here in a bit. But this mailing list object is going to be the thing that we define that allows us to iterate through those things that we have specified in these check boxes, these guys. Here's the form. Just a plain old form. You can see form 1, form. I initialize components, but then I do this thing called populate member list. And that's a method that I wrote, and its purpose is to simply give us some data to mess with. And then these three methods right here, these check changed methods, are the ones that get called when pig roast check changed is called, family check changed is called, or Christmas check changed is called. And if you look at one of them, it simply says call check changed, and that's this method down here. Actually, if you look at any of them, they all are the same. So let's take a peek at this. What this does is to create a new mailing list. And it seems like you're probably going to get a list of members or a list of somethings in there. And that list is going to be abridged based on these checkmark values. But that's not the case at all. What we're going to do is pass this entire member list in, and it's simply going to decide based on these things which values to deliver in a sequential fashion. So when this thing right here gets called, it's going to be called based on this object here, and it's going to ask for one at a time delivery of these members. The members on whatever list makes sense based on what got checked. And then when it gets this list created, it calls the populate list box, and that's where we get one of these, display it, get one, display it, get one, display it. So what I want to do is now show you what this member class looks like. It's really pretty simple. It's just a class and it's got a name and lists, and the name is this portion right here, Deb, and the lists, m_list, is this string right here. So those are there just to show you that you can do whatever you want. I mean, you can have as many things here. You can have address and phone number, email, whatever you want here. But this was just to show you how to have multiple ones and show up in that list box. And if you use the toString method, then if you look in here, we simply call the toString method on the member that came out of the mailing list and add that string to the items collection on the members list box. That's all it amounts to. So how does it know to do that? Because, for example, as I showed you, if we think about it and I click on this, Deb is first, but if I click on pig roast, Dave is first. And in fact, Dave is the first one, as you can see here, but by clicking on Christmas and not pig roast, I didn't get Dave at all. How did it know to go to Deb instead of Dave? Well, it knew because it created a mailing list for things so checked. If all we wanted was Christmas, and that was check, not check, not checked, then it would be those things that had a capital C regardless of what other values were there. In particular, Deb, Terry, Brian, Bob, and that's it. So let's go see what mailing list looks like. This is mailing list right here. Notice that mailing list is an IEnumerable, and this means that it's a generic for members. This is an enumerable for members. I stands for interface. This means that this is an interface enumerable required for the mailing list. So let's go take a look at what interface enumerable means. IEnumerable interface. It says that the methods that are required are getEnumerator, and that is it. There are some other methods here, but those are extensions that aren't required. The only thing that's required is that you provide a getEnumerator method that returns an enumerator object that iterates through a collection. Does that sound like anything you've seen before? If you look at the other two videos on the iterator, this is a concrete iterator. GetEnumerator is going to return an enumerator. It's going to return the concrete iterator, as the gang of 4 methods show. It's going to return one of these guys. But we're right here, so we're going to get an enumerator. Well, what's an enumerator? Well, let's go take a peek at GetEnumerator. get enumerator. What's it do? Returns an enumerator that iterates through a collection. And here's the return value. Return value is system collections IEnumerator. In the IEnumerator interface, look what it's got. Current, move next, reset. Now this isn't quite what we're expecting to see, as we recall from the .NET, or from the Gang of Four group, which says first, next, is done in current item. But if we look at what these mean, then we'll kind of understand. Reset sets the enumerator to its initial position, which is before the first element in the collection. So unlike having a first method, what we have is a reset method that sets us up so that we're before the first method. But in order to get to the first method, we simply call move next. Advances the enumerator to the next element of the collection. So if we're right before the first one and we move next, that will put us on the first one. And then if you look up here, current gets the element in the collection at the current position of the enumerator. So if we reset, we're right at position -1 is what we'll call it here. We click on, we call move next to be called, cause move next to be called, and move next moves us to position 1. Move next again would take us to position 2. Move next again would take us to position 3, except for one thing. If you look at what move next does, it says advances the enumerator to the next element of the collection, but that's only part of the story. It actually returns a Boolean value, and that Boolean value is true if the enumerator was successfully advanced to the next element. And it's false if the enumerator has passed the end of the collection. So as you can see, this thing right here, move next, is going to advance the enumerator to the next element if there is one, and it's going to return true. But if there is no next one, in other words, if we're already on the last one, it's going to return false. And it's undefined what we're looking at then. In any case, if we're on a defined element, if move next just returned current the last time it was called, or returned true, then current gets the element in the collection at the current position of the enumerator. And we can call current over and over and over without calling move next and still get the same thing every time. So essentially we're getting the same results as the Gang of Four got, except it is done and next and first are all kind of buried away in move next here. Reset sort of works like first by repositioning us to the beginning, except it pushes us in advance of that, and current then is pretty much like current item. So let's go take a look and see what we've got. Let's look at this IEnumerable, and it simply says return a get enumerator. Well, get enumerator is what we just called, except this is get enumerator from this. And we're essentially, it's not really an overload, but we're taking the place of get enumerator and returning a value from our own get enumerator. And our own get enumerator is here, and it returns an IEnumerator for members. In other words, IEnumerator of member is going to give us an enumerator that returns member values, not object values like this guy does. Okay? So you can go look up the IEnumerator versus IEnumerator of member. Probably take you a while to catch on to what's going on there. But this is a way to get the system collections IEnumerable get enumerator to return a member by calling that guy from inside this code. And I'm going to leave that part at that and ask you to go and read up on that yourself. All right. So here's the mailing list. What's a mailing list? It's a member list and a list of types. So it says sequentially grab the elements out of the member list that are of any of the types that are in this list of types. So let's go look at the constructor for the mailing list. Look what it's got in it. It doesn't have much. It's got this member list, and it grabs these values, or it creates these values in m_LTL. List type list is what that stands for. So that if you requested a list type of Christmas list and family list, then these two, Christmas list and on family list, would be true, and you would add the Christmas and family list types to this m_LTL for the mailing list. That's it. Now, let's see what else we've got to do. We somehow need to get to those values. In other words, we would like to get to the enumerator that we said we were going to provide as IEnumerator. But actually, let's go in here and look at this when we came up here. Let's look at IEnumerator right here. And look at that. It says return new mailing list enum using this member list and that list of list types. So how are we going to do that? We're simply going to end up calling this IEnumerator, which does this using this member list and this m_LTL, and we're going to get that enumerator. So let's go back here and look. That's all done in here. The for each knows that these structures are there. The IEnumerable and the IEnumerator structures are there, expects them to be there, and if they're not, it's going to crash on this part right here. But it creates this ML right here, so it knows already to use it. And it simply says, call that thing, that mailing list, to get an enumerator. The enumerator is going to be from mailing list enum, and then call it one time at a time. Essentially, call move next and tell me what you got. Move next, tell me what you got. In other words, move next puts us on an item. M is simply going to be current. And that's all done behind the scenes for you in this for each declaration here. And all we do is we just take this guy and put him in the string version of it into the items collection of that. And that's what updates the list box. Really kind of clean and kind of pretty. Let's go take a look at mailing list enum. Really not a lot to it. At least it doesn't feel like there is. So let's take a look at this. That's all there is to the constructor. Here's my member list. Here's my list type list. And I'm simply going to store those in these these variables, essentially global to the class, these class variables. And I'm going to call reset just to make sure we're at the very first item in advance, which is where we need to be before the for loop does anything. This probably isn't necessary, but that's what I'm going to do anyway. So I call reset. Then look what I've got. I've got this thing called current index. That's the current position in the list. If you look at this guy right here, current gets the element at the current position. Current index here gives me the current position. And so I've got this current that actually gives me the member. I've also got current here that gives me an object. This is a better place to understand the difference between IEnumerator and IEnumerator of member. Because you'll notice here that when I ask for it in the standard way, this is the way the for loop asks for it from the system collections IEnumerator, and I've just simply written this one, which would normally return an object to return whatever current sends, and its job is to return a member. And so even though this is returned as an object, it's still accessible as a member, and that's what's going on right there. But then look at this. Here's move next, here's reset. Reset, wow, that's not very complex. Just set it to -1, the index. And then when we do the move next, that's going to increment. Take a look what move next does. First thing it does is it takes the current index and increments it. And if we're already past the end of the list, we simply return false. And that says is done, is true. It says we've reached the end of the list. Otherwise, if we're less than that, well, for as long as we're less than that, with current index being less than the count of members in the list, I'm simply going to check to see if we're in any of these list types that we're in m_LTL, like Christmas and family, if that's what we picked. That's what we checked on the box. And then this piece right here says if member list of current index, I could just simply say current there, probably should. If the list type list contains the list that we just found, then return true. And that's because all it has to do is satisfy one of those. We could write move next as well if what we wanted to do instead of this was that it had to be in each of those. Then we would have to check all of them and make sure that the count was however many were in there. But in this case, all I wanted to do was make sure that I got the stuff where it was in at least one of those. And then m_current index ++. So I'm going up the list, looking at these guys and checking to see if any of them is in there. If I find one that's in there, in other words, one that contains that one of the list types, then I'm simply going to return true because I don't have to look any farther. There is this other little piece, though, that's not part of what we've done, and this is the dispose method, which has to do with garbage collection, and I'm not worried about it today. And as you can see, I don't have any code here, but it's really not part of what we're trying to cover with this particular coverage of the iterator pattern using the .NET framework. So just to reiterate what we've done, we've made it possible to go through 2, 3, 10 lists, I guess, even if you had them all in one big list. It'll go through them and pick out the ones that we selected, which gives you a sense that we can still use the iterator if we can come up with a way to sequentially produce the values without showing the underlying structure that contains the values. I hope that's of help to you, and thanks for watching. I'll have some more videos, hopefully quite soon. Take care. Bye.